Obviously, the integrand is e to the something, right? E to the negative x. And just by way of review, do you guys remember if you've got the antiderivative of e to the u du, what is the antiderivative? E to the u and then plus c, right? The question then becomes, is the du the correct du, right? Did Timmy mess up? Or did he not? So looking at this, what do you think? Did Timmy mess this up? A little bit. What did he mess up by? Yeah, so where we're getting that is to say that the exponent or the inside of our function is negative x. The derivative of that is negative 1. That needs to be the other factor in the integrand, and it's not. It's very fixable, though, like you guys all said. So we could rewrite this to be integral from 0 to 1 of negative e to the negative x dx. But of course, we can't just do that unless we also adjust the outside by multiplying by that negative. So effectively, what did we multiply by?
1.
By 1, right? Negative 1 times negative 1. We multiplied by 1. So we didn't change the value at all. We just changed the form a little bit. And then, now we're ready to find the antiderivative. So what happens there? So this negative 1 just gets put back inside. And the negative out here does not go anywhere. And then the antiderivative is just, as you guys said earlier, e to the u. So it would be e to the negative x. We're not going to put the plus c here because it's a definite integral, but that's the antiderivative right there. Do you have any questions? Can I say one brief word about something that I see still kind of creeping in to work from time to time? I will see folks do this, where they find the antiderivative and they leave this symbol on there. I still see this from time to time. What does the tall skinny s tell you to do? Yeah, saying find the antiderivative. So didn't we just do that? Yeah. So that symbol should not be there anymore. How do we note the fact that we're going to be evaluating from 0 to 1? Yeah, the line, right? The line on the right. So just a vertical line evaluator from 0 to 1. That's the right notation that we want to see. So once you find the antiderivative, this tall skinny s, not there anymore. Vertical line indicating how we're going to evaluate. Final step would be to evaluate using FTC1. So we could say this equals negative e to the negative 1 minus negative e to the negative 0, or of course you'd probably just put 0 there. To clean it up a little bit, as you would have to on a multiple choice, what's e to the 0? 1. That's right. So this could equal something like negative e to the negative 1 plus 1. You could obviously flip the first term around a little bit, manipulate that if you want, but that would be a fine answer.
So you wouldn't have to solve.
You wouldn't have to what?
Like no. Okay, never mind. Yep.
Yeah, you wouldn't have to flip it. And without the calculator, we really can't go much beyond this, right? So, all right. Will you guys do number 7? Will you try it on your own? See how it goes for you, and we'll work together to make sure it's good. So, hope that you'll ask questions, right, if you need to. So, the way that you could approach this, kind of the way of thinking that I would at least advise you on is to say this. Look at your integrand first. Your integrand is a product, something times something else. And maybe more importantly than that, one of the two factors is a composite, right? It's cosine of e to the x. E to the x has been put in as the input for cosine. And so we want to check basically the pattern of the chain rule, see if it's really there. The way you do that is you look at the inside of the composite, which is e to the x, and you ask yourself, is the derivative of that inside the other factor? The derivative of e to the x is e to the x. And so for once in a long time, Timmy totally did not mess up at all, did he? It's been perfectly done. So when it has been perfectly done, what's going to happen is this. The e to the x is going to go back inside, and we anti-differentiate cosine. So maybe your next step could look like this. Sine of e to the x evaluated from negative 1 to 0. If you have your doubts, and I would respect you for sure if you had your doubts, if you look at that and you think, well, I don't really think that sine of e to the x is the antiderivative of what we started with, how could you check to confirm that? Just do a derivative, right? And you would see that you'd get cosine of e to the x times the chain rule. You'd get an extra e to the x, just like that integrand hand at the start. So, I hope that confirms it for you. In any case, we do FTC1, sine of e to the 0 minus sine of e to the negative 1. And as we saw last time, e to the 0 is 1, so maybe we could write this as sine of 1 minus sine, we could write it as 1 over e if we wanted to. Not necessary, but it's okay. Without a calculator, it's about as far as we could be expected to go, and we'd be done.
Well, we know sine of 1.
Are you sure?
Well, I guess because it's like all of them. It's like
Well,
pi over 2 and then like 5 pi over 2.
no,
No?
no.
Totally kidding.
Why is sine not pi over 2?
Sine of 1 is not pi over 2. Inverse sine of 1 is pi over 2.
Oh.
Freaking confused on all the
It's like
Okay. I'm a little lost.
it goes
Sine of
pi over 2 is 1.
Number 8 is integral from 0 to 1 of e to the x over 1 plus e to the x. Hey guys, girls, it's a fraction, and normally we kind of run away from fractions. Hopefully not crying and screaming, but we run away from them. But remember in this chapter, for the first time we learned, that we might have a way to deal with certain types of fractions. So I would suggest that you think about, could we actually deal with this as a fraction? And if you can, go ahead. And if you can't, you're going to have to do it a different way. So I encourage you to think along those lines. I'll leave it at that. See if you can handle number 8. I'll check on you in a minute. Like I kind of introed with you guys, obviously the integrand is a fraction. And in the past, we have tried to avoid that. But I'm going to tell you right now that as we move forward and we start to see a few more of these different fraction sorts of things showing up as integrands, the first thing I want you to think of is, does this lead to natural log? The answer sometimes is going to be yes, other times it's going to be no, but I want you to consider that first. Is this going to lead to natural log? And the way you determine that is to ask yourself, is the derivative of the denominator the top? Is it the numerator? So the denominator is obvious up there. What's the derivative of the denominator? E to the x. And you look at the top, Timmy is on a 2-question winning streak, right? He totally did not mess this up. So what we would do then is we would write our antiderivative. Our antiderivative would then be the natural log of the denominator. And then we're going to evaluate from 0 to 1. We'll do that in a second. So it's very critical that at least my approach seemed logical to you, so you can kind of start to make that work in your mind as well. So does my approach as far as how we handle that fraction, does that seem logical? Do you have a question? Does that fill in the blank for you?
Yeah.
Okay.
For some reason, I was thinking that the numerator had to be 1 for you to be able to do that.
It could be anything as long as it matches the derivative of the denominator. Yep. Okay, any follow-up questions? Anything? All right. Well, then we do FTC1. So we would say ln of, we really don't need the absolute values now because 1 plus e is positive. So it would be ln of 1 plus e to the first minus ln of, I guess it'd just be 1 plus 1 in the end, wouldn't it? E to the 0 is 1. So ln of 1 plus e minus ln of 2. And certainly that's about as far as you could go. There is one other step. We were talking about it there in the back. If you wanted to kind of neaten this up a little bit, you could use a log rule. Do you remember that log rule? If you're subtracting logs, you could condense it into division. Yep. So you could write this as natural log of 1 plus e over 2. That would be an equivalent expression, but unless we're trying to work with some multiple choice that has that sort of thing, there's no need to do that. So don't feel like that's required.
Are those rules only for natural logs or all logs?
Not for all logs, but the bases have to match. So if you had like ln of 1 plus e minus log base 10 of 2, you can't do that. The bases have to be the same. All right. Any other follow-ups? Okay, please get your calculators out if they aren't already out. We're going to do number 9 and number 10 with the calculator. This will be a good review.
This one you have to do the absolute
Oh, what was that? Oh, wow.
So, number 9 is an excellent example of how these skills that we've been working on might be used as an application. It's the old stuff, just like we've been doing. Number 9 gives us the idea that a particle is moving left and right along the x-axis. The velocity is given by that v of t function. And it says, A, find the displacement on the interval 2 to 4. B, find the total distance traveled on the interval 2 to 4. And so what I would ask you to do here, I think the logical thing is to use the calculator, but please show your setup and then use your calculator to actually evaluate that setup. So give it a try. Like I said, this is old stuff, but it doesn't mean that it's easy. Yeah, give it a try. We'll check your answers in a little bit. So let's just boil this down to what it is. I put these two questions together for a reason, to kind of compare and contrast them. These two questions are really the same except for one set of symbols. What is that symbol?
The absolute value.
So which one gets absolute values? Is it displacement or distance traveled?
Distance traveled.
Distance traveled gets the absolute values. We can talk about why that is later if you want. But here's your setup. For displacement, you'd say integral from 2 to 4 of v of t dt. For total distance traveled, it'd be the integral from 2 to 4 of absolute value of v of t dt. So they look the same except for the absolute values. Guys, here's a quick way to think about it. Distance is always positive, right? Your car has an odometer which measures distance. There's no way that that could be negative or go backwards unless you break into it and break the law and make it go backwards, right? Displacement can be negative depending on which direction you're going. And so since distance can never be negative, that's the absolute values, ensure that, and that's why they're in there. So, did anybody take this through to Math 9 and get some answers?
Yeah.
What'd you get? What'd you get, Austin?
4.494.
4.494. 94.494. And the other one?
94.494.
Interesting. So they were the same. Now, have you ever seen that before?
Yeah.
Pretty much all the ones we've done, haven't they been a little different?
Well,
The absolute values have made a difference, haven't they?
that's just when something like changes direction and goes
That's
back the other way.
it. There you go.
E can't go below 0.
Well, but we just because of the fact there's an e in there doesn't mean we
When you're
couldn't.
taking it to the power, it can't go.
Right, but if we had like a separate term in there, we certainly could,
Yeah.
right? Yeah, at least on this interval, right? 2 to 4, apparently, yeah. So that's the conclusion I'd want you to make. If the total distance traveled and the displacement are the same, that means the particle never changed directions. It just went in one direction, that's it. Okay, so our final example in our notes here is number 10. You guys would flip on over to that. We'll take this, we'll work through this as quickly as we can, see how it goes for you. At this question, we'll look at A here together. So it says the number of gallons P of T. So P of T is an amount. P of T is not a rate this time, it's an amount. So the number of gallons P of T in a lake changes at the rate of P prime of T equals, and that gives you that equation right there. So P prime is a rate, P of T is an amount, P prime is a rate. T is measured in days. There are 50 gallons of pollutant in the lake at time T equals 0. The lake is considered safe when it has 40 gallons or less of pollutant. All right, so part A, question A says, is the amount of pollutant increasing at time T equals 9? Why or why not? So this is a very old question. This is from chapter 3. So this is from October-ish. And so let's think this one through. What would be kind of our framework of thinking? Well, we could say the amount of pollutant is increasing at T equals 9 because
The rate is positive.
the rate at 9, right?
Yeah.
And instead of saying the rate, specifically what function would we be working with?
P prime.
P prime. So if P prime of 9 is positive, like you said, then the amount is increasing. So can you guys confirm or deny that?
Yeah, sure.
Go ahead. Use your calculators. This is definitely calculator active.
Yeah, that's nice.
Let's confirm or deny that the amount of pollutant is increasing at T equals 9. You want to know why or why not. So we'll need some numbers and some reasoning to kind of back this up.
It's positive.
It is positive? We'll check Austin's number here in a second. You got P prime of 9 equals what?
0.496.
You guys agree with Austin's?
0.504.
504.
Yeah.
Did you do the 1 minus?
No.
Ah, okay. So do you guys agree 0.504? Okay. Yep, if you add those two up, you get 1, don't you? Yeah. Okay, so 0.504. And what is the most important thing about that number?
Positive.
Positive. So we could say something like that, greater than 0. So we can just jump right there to our conclusion. We can say, because P prime of 9 is positive, therefore the amount of pollutant is increasing. And we've got it. So we're still striving to like go back in time and make connections for you with old stuff in chapter 3 or chapter. We've been using chapter 2 a lot. Chapter 3 on this one. I think it's a good thing to do that. B. Yep. Interesting question. Okay, so B says, for what value of T will the number of gallons of pollutant be at its minimum? Justify your answer. So, how do we justify, or like, what's the framework for determining whether we have a minimum or a maximum or neither or whatever? Find critical numbers. Yeah. So I want to ask you guys a question that I think is pretty important for us to discuss. Are there any endpoints for us to consider? I see the 0, right? T equals 0, that's our starting value. So that, like, you could kind of think of that as an endpoint. Yeah, there's not really another endpoint for this. Let's kind of hold off on the endpoint idea for just a second. Let's go ahead and take the advice that you gave, and let's see if P prime of P prime of T does actually equal 0. Again, calculator active, right? So here's what we'd want to write down. To follow your guys' idea, we would want to write this down. Say it again. You must write that down. Anytime you set something equal to 0 or write some important equation in your calculator, you want to have that down on your paper as well. So critical numbers where P prime of T equals 0, please use your calculators to actually solve that, and then we'll try to use that. So this is kind of a chapter 3, maybe 4-ish, 4 might be kind of brought in a little bit, but mostly chapter 3 on this one. P prime of T equals 0. Let me know when you've got an answer. Well, let's check it. Let's hear what you have.
I got 5.493.
5.4. And that's it, right? Just the one? There were no others? Okay. Can you guys confirm that? Is that you do agree? Okay, we're getting some yeses on that, Macy. Thank you, everyone. Okay. So, refer back to your calculator graph if you want, but at that place where P prime crosses the x-axis, is P prime crossing from negative to positive or positive to negative? Okay, so doesn't that start to give us a sense of what might be happening here? If P prime goes from negative to positive, then P has a minimum. Yeah, there you go. So I think you can use your calculator there for sure. I think we can simply say, P prime goes from negative to positive. I'll put only at T equals 5.493. Therefore, P of T has a relative minimum. Then I personally kind of like the using the intervals that we talked about in the first semester a little bit. I think this is going to be okay, but a global argument using just intervals, like P prime is negative from 0 to 5.493 and then positive from 5.493 on. I think that would, maybe be a little bit better, but I think we're going to be good with this. Okay, how we doing? Still hanging in there? All right. One more here, at least on my screen. I know there's a D as well. This one, I think, is an important question. It says, is the lake safe when the number of gallons of pollutant is at its minimum? Justify your answer. So what's that acceptable level of pollutant? 40 gallons. So how do you think we're going to be able to figure out how many gallons there are in the lake at that 5.493 that we just found?
That T into P of T.
Okay, so, but we don't have P of T. We do have, so we have to integrate. We're going to have to use an integral because the only thing we really do have is that P prime. Now, personally, let me look at this. You could do this by doing an indefinite integral and finding the C. I think we have enough information to find that. but I think because the calculator is active, it would be better to use a definite integral so that we can use Math 9. Okay? So can you think of a setup? What might be a good setup to determine the number of gallons in the lake at this time we just found? What do you think, Natalie? Go ahead.
I put down 50 plus the integral from 0 to 5.493 of P RT.
Okay, so did I get everything? I put a DT on there too for you. Did I get everything down like you said?
Yeah.
Can you explain why you put what you put?
Well, I put 50 because it starts with 50 pounds.
Stop right there. Does that make sense? It says when t equals 0, there's 50 gallons. So I think starting there makes sense. And then what about the rest of it?
That shows the amount of change that happens.
Yeah. So 50 plus whatever the change is, that should give you how much is actually there. It's very logical. Great setup, Natalie. Thank you. Any questions on that? I thought she did a good job explaining why she chose that. Is there anything you want to follow up with? All right, well, let's follow up with Math 9 then. So let's go ahead and evaluate that, and then we can decide, is this lake safe ever, right? Because this is going to be the minimum amount. So if it's not safe now, it's not going to ever be safe, right? What is the number?
45.493.
Ooh, 45.493. We coming to a consensus on that? When you math 9. So, that's obviously bigger than 40. So you better not swim in this lake, right? So, the question says, is the lake safe? Really, your big answer is no. It's not safe, apparently. You guys all get that same number, 45 point something? So I think we be confident that that's good. So yeah, don't swim in this lake, ever. It's going to be bad or worse than this. Any questions? Any hiccups or anything? Delaney, McKenna, you guys good? You're good? Okay. All right, well, let's look at the final question on this one. That would be part D. Can I scroll? I can scroll. Okay. So it says, part D, it's not going to show up yet. You can look at your notes here. It says an investigator uses the tangent line approximation to P of T at T equals 0 as a model for the amount of pollution in the lake. At what time T does this model predict that the lake becomes safe? P prime we got, right? P prime is definitely not linear, so an investigator is going to use a tangent line to approximate. Boy, that sure sounds scary to me, approximating pollutant in a lake and using that as a basis for swimming in it or not. An approximation, really? But that's what this guy's doing. So he's going to be using a tangent line approximation based on T equals 0. So let me ask you those questions again. If you're going to be trying to find the equation of a tangent line, what are the two things you got to have?
Point and slope.
Yep, point of tangency and slope of the tangent line. How do you find the slope of the tangent line? The derivative, right? The cool thing is don't we already have the derivative? They gave us P prime. And the point of tangency would be what?
Where T is 5.
When T is 0, right? Because it says, do you have your notes in front of you?
I do not.
Sorry, I'll get off my screen here so you can see it too. It says that the investigator uses the approximation to P of T at T equals 0. Oops. There we go. So that would be the component of our point of tangency. So that's what we're going to use. Does that make sense? Okay. So let's go about that. Let's see what we can do with. Let me get onto a better screen here. You guys have that equation. Actually, I'll write that equation down here too. P prime equals. So I've got P prime equals, 1 minus 3e, is it negative 0.2t? So negative 0.2t. So I can use that to find my slope, right? And the truth is, I could do this without a calculator, right? Because what do I plug in for t to find the slope at my point of tangency? 0, yeah. So I could write P prime of 0 equals 1 minus 3e to the 0 which is just another way of saying e to the 0 is 1, so the whole thing would be
0. Oh, 3.
negative 2, right? 1 minus 3. So that's my slope, negative 2. But then, so I got a little issue here though. Maybe you guys see the same thing. I know that when t equals 0, that is my, it's part of my point of tangency. Don't we have to have a p-value to go with that? How are we supposed to figure that out? If you look at your notes, those of you that have your notes in front of you, it's on your page. 50. When t is 0, p is 50. That's just told to you directly in the stem of the question, not in this part, but you want to recognize that those two data points go together. So as far as our tangent line, tangent line could be, I'll use y's and x's here perhaps. Well, why don't we use p's and t's? Can I use an output of p and an input of t? Does that work? Okay. So we'd say p minus 50 equals negative 2 times t minus 0, using that point slope format. So that's my tangent line equation. And then it says, at what time t does this model predict that the lake becomes safe? So how would you describe that? When does the lake become safe? When what is 40?
The P of
P, specifically the letter, not T, the P, right? Because T is time. So when P is 40, that's when the lake is safe. So what could we do with that equation to find this time? Yeah, plug a 40 in for P. So that's what I'll do. So 40 minus P, or 40 minus 50, excuse me, equals negative 2T. So, that's negative 10. So I'm coming up with 5 hours. So when T is 5, the lake, according to this model, the lake will become safe. Or is it days?
Yeah.
Sorry, I lost my units there. I don't have them in front of me. So 5 days. Now, think about what this means. If you think back to what we said in part B and C, remember B we found like the minimum, like the time when the pollutant was at a minimum. Wasn't that like 5.493? So this number 5 is pretty close to that, right? That makes sense. So this would be, when the lake becomes safe. Yet we know from before, based on the curve that we used, that's not really true, is it?
It's not ever going to be.
It's never going to be safe, but the approximation would tell you, yeah, it'll be safe in about 5 days. According to the curve, maybe not so much. So that makes sense. Looking at it from a couple different perspectives there, an approximation and then maybe an exact value. Of course, that all depends on how accurate that model is, but there you go. So I love doing this with you guys because doesn't this force you to dredge back into the depths of your mind and bring out old stuff? This is where you start to get really, really good at this because you got to remember and remember over and over and over again. You start to see it as a holistic thing as opposed to chapter 4, chapter 5, chapter 3, whatever. So we got plenty of time here for a little bit of Q&A stuff. Can I show you the stuff I wanted to show you? I'm just going to include this as part of the video, I think. So give me 1 second. Let me show you what I wanted to show you. Two main things. It's worth pointing out, and this is why I wanted to do this. I make these reviews for a purpose, for a reason. I hope that you take that to heart. So within this review, we see something that's kind of odd. It'll show up on the AP test for sure. I'll assess you on it as well. The thing I just put in the box right there is kind of unique looking. It's defining a function as an integral, right? It's saying g of x is the integral from negative 4 to x of f of t dt. And so what's unique about that is it's basically like an accumulation function, right? It's accumulating area from negative 4 to wherever. Have you guys done the review? Have you seen this one? If you have not, you need to, okay? The complete solutions are there. I thought I'd point this out and do some of this with you. I'll leave C and D to, for you to kind of explore. But you want to be good at this. I promise you I will never on purpose waste your time. So me making that review and having you take that with you would be a total waste of your time if it didn't have application in the very near future. So please consider. So look at what we're supposed to do here. We're supposed to find g of negative 1. So going back to like old Algebra 1 stuff, whenever you see g of negative 1, doesn't that just mean plug a negative 1 in wherever you see an x? So that's what we would do. We would say, I'll just come over here and say, let's find g of negative 1. Well, using this function right here, I would say, well, g of negative 1 means the integral from negative 4 to negative 1 of f of t dt. Great. How am I supposed to handle that? What am I supposed to do? Yes, if you can't integrate, because we don't even know what the function f of t is, we know what its graph looks like, you can't integrate, accumulate area. So I would just accumulate from -4 to -1, so that would be from here to here. What would you guys do with that shape? It's a trapezoid. I like the idea of a trapezoid. Couldn't you also split it up into like a rectangle and a triangle? Trapezoid would be the most efficient way, maybe because it's just one shape. But you could split it up and find the area of those two things and add them up. Then the one thing you want to consider is because that area is all below the x-axis, your answer had better be negative, right? So the rectangle is 1, 2, 3 by 2, so that's 6, and the other is 1, 2, 3 by 1. I'm coming up with 7.5, so I think we'd get -7.5 for that one right there. And then the next one, right, g prime of -1. In order to find g prime of -1, what do you have to find first? G prime of x, right? So you do that first, and then you plug in the -1. Check out the beautiful thing that shows up here. I know that g of x equals this, so to find g prime I need to differentiate both sides. Check this out. G prime of x equals d dx of the integral from -4 to x of f of t dt. Didn't I just differentiate both sides? What accidentally snuck up on you on the right side? Big concept.
Oh, it's the FTC2.
FTC2. Do you see it? d dx of an integral from -4 to x of f of t. So you use the FTC2 trick here. So what you do is you would say that this derivative and integral cancel each other out. The x drops in wherever you see a t, and you multiply by the derivative of what you dropped in. Well, what's that derivative? So that's not going to really show up and make much of a difference. This would simply just equal f of x. So it'd be g prime of x equals f of x. So to find g prime of -1, which is what we were asked to do, we just need to find f of -1. These are all important things to make sure you write down and connect g prime with f. So f of -1 is -2. So equals -2, game over. And then the final one, g double prime. If you're going to find g double prime of -1, don't you have to find g double prime of x first? So what I would do is I would start off here. I know what g prime is, so to find g double prime, don't we just have to differentiate one more time? So what's g double prime equal to? Yep, so g double prime of x equals f prime of x. So g double prime of -1 equals f prime of -1. And what would you say that equals? What does f prime describe about f? Its slope. So what's the slope of f right there at -1? Does not exist, right? Isn't that one of those sharp points where two line segments joined? Now they joined, but it was not a smooth joining. So you'd say for this one, dne. They kind of gave you a little hint here. They said find the value or state that it does not exist. It'd be sort of cruel to say that and then have all of them exist, right? And so maybe that's a hint. It's possible that they could do that to you, but that was a hint to at least consider that, and that's the one that doesn't exist. So that's kind of unique notation. So that's why I put that in the review and wanted to bring that out today. Does that make sense to you guys? If you can do problems like that, you're showing some real growth and development, and you're going to be in good shape. So I want to show you that one other one, and at least just remind you of something on that other one. So I'll skip over to that. Is that okay? All right. So I've given you plenty more material to work with there. There's like the h of x function comes up a little bit later. Plenty to work with, but thought I'd show you that. So for this other one is back up here at the top. Please, please, please do this review. If you haven't already done it, it's going to be a good thing for you. Okay, so this one right here uses some really key language. It says, find the particular solution of the differential equation given the initial condition. So the differential equation is right here. Remember, a differential equation is any equation that has one or more derivative. Can anybody explain to me what you maybe would want to do with like just a slight little rewrite before you got going with this one? Say again? I think that's wise. There's another thing you could do. I'll go ahead and do that. So I'll write f prime of x equals negative 2x to the negative 3. I think that is a good move, but I think there's one other thing you'd want to do. Negative 2 outside of what? We haven't done that thing yet. You said change f prime to what?
Different.
We want to change notation. Let me take a peek at my time here. Let me share this with you. F prime is that Newton's notation, right? What's the other guy? Leibniz? What's his notation? Yeah, ddx thing, right? So I would rewrite this to be dy dx equals negative 2x to negative 3. Why on earth would I bother rewriting like that? Got to separate the variables out, right? With that f prime of x, it's like, you can't really separate it so well, but we want to part them on each side of the equal sign. So what you would do is this, dy equals negative 2x to the negative 3 dx. Now you've got all your y's on one side, all your x's on the other side. This is right out of 4.1. Remember, that's the step right there where if you show it, then you have the opportunity to earn all the points that follow. If you don't show it, it's 0 out of whatever. You've got to show separation of variables. Now what you would do from here is you would integrate both sides because we want to get the function that would result in that derivative. So we would get y equals, I'll see here, it's going to be x to the negative 2, isn't it? Plus c, when you do the power rule for integrals. And then how do you find the c? The initial condition up there? Yeah.
Plug in 1, 6.
The 1 for x, the 6 for y. Yep, so 6 equals 1 to the negative 2 plus c. So I'm getting 5 for c. So my final answer would be y equals x to the negative 2 plus 5. And that's that. So I wanted to show you those two right there. The first one, because it's notation that might be a little unfamiliar with you if you haven't seen that review before. And this is one where I feel like if you guys just remember to separate the variables, you're probably all going to get like 4 out of 5s and 5 out of 5s. If you forget to separate the variables, there might be a lot of 0 out of 5s, and I don't want that for you, so I thought I'd show you that one more time. So, hey, I'll post this video for you. You can feel free to check it out if you want. Otherwise, I'll see you early on Tuesday. Have a great weekend.